So two sets again, one is less than 120 and one is going to be less than 90. So let's look at AX3E2. You'll notice there's a lot more combinations we can get to once we're talking about lone pairs. This is called T-shaped, and we had briefly discussed that, but not mentioned what the angles would be.
So what angle would you have here? Yep.
All right, great, less than 90 degrees. So we'll start a new page here and talk about AX2E3. And we'll let you tell us what this geometry is. Yep, so I hear a lot of linear out there. And you need to keep in mind we give the names based on where the actual bonds are, not where the lone pairs are, even though the lone pairs, of course, affect the structure and the geometry. So
the angle?
Yep, 180.
So it's exactly 180 here, not less than.
So for AX5E, what we have here is called square pyramidal. This is square because of the 4 square at the bottom of your pyramid. Then you can picture the pyramid as you go to the top.
And so what angles would you have here? Yep, less than 90.
So less than 90, great. All right, there are more. So our next combination that we can think about is if we have 4 bonded atoms and 2 lone pairs, AX4E2. That's going to be called square planar.
So again, we have the square and it's planar. And so what are your angles here? Yep, exactly 90.
So next, let's look at AX3E3. This is what we call T-shape. This is also T-shape.
Okay. And angle here?
Yep, I think we heard less than. It's less than 90 degrees. And let's look at AX2E4. And again, you guys can tell us what this geometry is, first of all. Yep, it's linear. So we have lots of different ways we can get to a linear molecule, some of which have lots of lone pairs, some of which have no lone pairs at all. This is linear and 180 degrees. All right, so we'll do just a few examples to show you some actual molecules that have these geometries. We won't go through all of them because, as we saw, there's lots of different combinations we can have once we start getting into lone pairs. The first we'll look at is water here. And water is a good one to look at because we've seen that at the beginning of class here when we're talking about polar molecules.